discussion on motion. So when we talk about motion, what are some of the things that pop up in your mind when you describe motion? Maybe describe your trip to school this morning. Maybe you would talk about how fast you were traveling. We might talk about whether or not you came to a stop, whether you traveled at the constant speed or whether you slowed down and sped up. You may talk about how far you went. You may talk about where you ended up compared to where you started. Like, were you in Sanford and then went to Lillington, or did you go from Cary to Raleigh? All of these aspects are considered when we talk about motion. Let's first talk about distance. The distance you travel is how far you travel. So in this particular example, if I start at one location, it doesn't matter where I go or where I end up, just how far I've taken. The path I take has nothing to do with how far I've gone. And that is called my distance. And because it has nothing to do with direction, it's just the sum of all the distances I've walked. So maybe I walked to the northeast 5 miles and then to the southeast 10 miles. My total would be 15 miles of distance. But my displacement in physics is my change in position. So I started here and I ended up here. So my displacement is how far and in what direction I am relative to where I started. And as you can see in this example, the magnitude of my displacement, the value of it, is way different than the distance. Distance and displacement are both measured in meters, but one is associated with a change in position, and that means that you have to also designate the direction that you went. So, for example, you might have walked 15 miles total, but maybe you're only 5 miles southeast of where you started. So the displacement is your change in position, and your distance is literally how far you traveled. So that brings into question, why is there a difference between these two values? Because distance is a vector. It has magnitude and direction. And scalars, like distance, only have magnitude. They have nothing to do with direction. In physics, there are lots of quantities that have direction associated with them. And there are quantities that have nothing to do with direction, like mass or time or distance. We're going to learn more of those today. So let's do a little bit of practice. First, let's find the total distance that each of these have traveled. So I'm going to make a chart of distance in meters and displacement in meters. And I'm just going to do that for each point, for each segment. So A started at 0 and it ended up at about we'll just say 7 meters. So its distance was 7 meters, but its displacement is 7 meters east of where it started. In B, it started at 12 and it ended up at 8. So it's 12 minus 8, or excuse me, 8 minus 12, or 4 meters from where it started, or negative 4 meters, which means that it's to the west of where it started. So in physics, we can designate positive and negative directions. East will be positive and west will be negative. North will be positive and south will be negative. In this case, we're only dealing with things that are going east and west. In C now, we've done something different, right? We started at 2 and we went to 10. So we went 8 meters. and then we went negative 2 meters, and then we went positive 3 meters. So we went 8 meters and 2 meters and 3 meters. So we went a total of 13 meters, but our displacement is positive 8 meters plus negative 2 meters plus positive 3 meters. So that's going to be a total of 9 meters in the positive direction, which means that we traveled east of where we started. So remember, we ended up 9 meters east of where we started. Now let's look at D. D traveled from 9 to 3, so 6 meters to the west, and then 1 meter to the east. So 6 plus 1 meters equals 7 meters total distance, but the displacement is negative 6 meters plus positive 1 meter. We ended up at 5 meters to the west, or negative 5 meters. So would it be okay for you to write 5 meters west or to write negative 5 meters? So what's the difference between average speed and average velocity? Speed would be your total distance divided by your time, and velocity would be your total displacement by your time. The only way for these to have the same magnitude value would be for you to be traveling in one direction. For example, if I travel 10 meters in 2 seconds, my speed to the east, my speed would just be 10 meters divided by 2 seconds, or 5 meters per second, my average speed. My average velocity would be my displacement, which would be positive 10 meters in 2 seconds, or positive 5 meters per second, or I could write 5 meters per second to the east. But what about this track? Okay, let's say that this race car travels an average of 180 miles per hour in one loop. The average speed is going to be 180 miles per hour, right? And I could change that to meters per second if I wanted to. But the average velocity is the displacement divided by the time. Well, if we just do one loop, I started here and I go all the way around and I end right back where I started. So my displacement is 0 divided by whatever the time is. So my average velocity would be 0. So the only way for them to have the same magnitude would be for them to be traveling in the same direction for the same amount of time. But when you start changing directions, you're not going to have the same value for velocity, average velocity and average speed, because your distance and displacement are going to be different. So we had some values here. So let's just do one example. Let's say that it took 2.0 seconds to make all these different trips. So let's just look at C. So the average speed would be the total distance. Well, the distance was 8 plus 2 plus 3. 8 plus 2 plus 3 meters divided by 2 seconds. So 13 meters divided by 2 seconds is 6.5 meters per second. Notice that I'm showing you my units, and all the time, I'm not just giving you answers. I expect you guys to do the same thing. And my average velocity, though, is going to be the displacement. So we went positive 8, negative 2, and positive 3. So positive 8 plus negative 2 plus positive 3 meters all over 2 seconds is going to be 8 plus negative 2 is negative 6 plus 3 is positive 9 meters. So that means that you're to the east of where you started in 2 seconds, or positive 4.5 meters per second. Also, we can use dimensional analysis and our understanding of the formula for speed to calculate things like time. So imagine that you have a sound wave traveling at 330 meters per second at room temperature. If your ear is 57,300 meters from your source, how long does it take the sound wave to get to you? Well, we know that speed equals x over t. That's the formula that we've been using. So if we want to know t, we're just going to solve for t by multiplying both sides by t. T is going to be equal to x divided by v, which is going to be 57,300 meters times, let me just erase that, divided by 330 meters per second. So when I put that in my calculator, 57,300 divided by 330, I get 173.6 or 174. And let's just show you how the units are. Minutes divided by meters per second is the same thing as meters times seconds over meters. So I'm left with seconds, 174 seconds. So what is your speedometer telling you? When you look at it, are you seeing the average speed or the instantaneous speed at that instant? Well, obviously it's the speed at that instant, because most of the time you're driving down the road, you are not traveling at the same speed, right? You're changing the speed. So there is a difference between average and instantaneous speed and velocity. Instantaneous speed is the speed at that instant, and instantaneous velocity is the speed and direction at that instance. So constant speed, in order to travel at a constant speed, just to review, you have to travel the same distance at each instant in time. But in order to have a constant velocity, you have to travel the same distance each instant in time and in the same direction. So if you were traveling in a circle, right, at a constant speed, you may travel the same distance every instant in time, but your direction is changing depending on where you are. So it is possible for you to travel at a constant speed, but not a constant velocity, if you are changing direction during that time. And that also means that if you're not traveling at a constant direction, even though your speed is staying the same, there must be something making you change your direction, which means there's a force acting on you, which means that you are